Resolving forces on objects in equilibrium. If there's no acceleration, this can mean that the object is either stationary, which is static equilibrium, or moving with constant velocity, dynamic equilibrium. Acceleration is zero in both cases. So Newton's second law, F equals ma, force equals mass times acceleration, with acceleration being zero becomes F equals zero. Importantly, F is the resultant force, which means the total of all forces acting along a particular line. Horizontally, that means the forces to the left minus the forces to the right give the resultant force, and they equal zero. So you can just write forces to the left are equal to forces to the right. Similarly for the vertical upwards and downwards. And likewise, if you're working on a slope, you do the same with the parallel and perpendicular directions. So, looking in this video at just a box on a flat surface, the box has 4 forces on, and 3 of those forces are either vertical or horizontal, but 1 is diagonal. So I've resolved that into two components, horizontal and vertical, and I've marked them with different colour highlights so I can make sure I include all of the forces. So looking at the horizontal direction, T cos alpha in one direction minus friction in the other gives 0. So I can just write that as T cos alpha equals friction. And in the vertical direction, reaction plus T sine alpha is minus W equals 0, and I can balance those forces like that instead as well. One of the reasons for highlighting the 3 forces is so that we don't forget this. This is a really common thing to do when you're resolving, is to just say that the reaction is equal to the weight. But when we add tension, the tension actually reduces the reaction force by the value of the tension. So I'm going to put some figures in now and work out some values. So I've given a value to some of the things, friction, the degrees in the tension there, and a mass to the box of 2 kilograms, so that means we multiply that by gravity to get the weight of the box. So now if I resolve horizontally, I have T cos 30 is equal to 3 newtons. So I've just balanced those out, and I've written it in exact form and to 3 significant figures. If I'm going on to use this in the question, I would want to use the exact value to avoid any possible rounding error later. Resolving vertically, R plus T sine 30, T now being 2 root 3, equals 2g going downwards. So just rearranging that here, I can put all of this straight into my calculator with g is 9.8 unless otherwise specified, and that gives me R equals 17.9.